Hi, my name is Dirk Fleischer. I'm a data manager at GEOMAR Helmholtz Centre for Ocean Research in Kiel, north of Germany. I'm responsible for the Kiel Marine Sciences, and I deal usually with georeferenced observational data. So my colleagues and I, we created a web application. We call it OSIS, or Ocean Science Information System, and it is publicly available. You can come to our portal and you click on OSIS and you will come to this general overview and search interface, but you can also go directly to the different cruise and leg information tables. So we have right now a little bit above 1000 expedition legs and faces in there. We have some numerical models and some sensor networks. What I want to show you is that we use this application as a basis for websites and a Google Earth export. So the folks from Google Ocean, they asked me to create this screencast to actually present how we use Google Earth to present exactly the same information in a georeferenced way on the virtual globe. So just to give you some background, I show you the KML tutorial area pages of Google, and under advanced KML documents you find network links, and what we use a lot is the view-based refresh queries. It's actually the HTTP GET that is sent by Google Earth to the server with the bounding box of the area on display. So you can actually use this kind of information on your server and query the database in a georeferenced way. So please read more on this page here about this feature, and I will show you now how you can actually use it. So now I opened Google Earth, and the North Atlantic is on display. A very small area of the Pacific is also visible, and here you can see one of our network links, and this network link is actually a kind of geo search. Due to the bounding box that is sent back to the server, we can query the database on the georeference of the bounding box. So this is the URL for the web application, and it will be extended automatically by Google Earth with the longitude and latitude of the bounding box. So you can put all these options here. You can set them up in the network link already. You can use this URL if you want. I can send you a copy of the GeoSearch KML if you write me an email. And now let's switch it on, and we actually ask for data for this area. It takes a while because it's a very large area, and since we have 1000 cruises and we really create the answer each time on request, so it's always the most up-to-date information. As you can see, the time slider appears here, so we provide you with time-dependent information, and So here we have the cruises and expeditions in our system for this area. So you see that we also have a lot of data from the Pacific side. And if I zoom in, I can click on one of the cruise tracks and I get the information from the Ocean Science Information System, a short cruise description, related files, how many data files we have in the system, how many literature has been linked to this cruise in our institutional repository, and some more additional links. So this is a very easy way to browse through all the tables with cruise information simply by the georeference of the cruise. And let me turn the world around to show you that in the Pacific we don't have any data as it seems right now, but if you refresh the network link, you will see here now we have some cruises available for the Pacific, and these cruises have published some literature. We have data files available and a short summary about this Sonne cruise 193. So if I zoom in below a certain level, like 10 degrees longitude spreading or 10 degrees latitude spreading, the response will change that you will get from our application. So let me zoom in a little bit closer. Here now you see that it's not cruise-based information anymore, it's actually gear-based. If you want to find out about all the dredges in our system, just uncheck all the gears and then check again dredges, adjust the time slider, and you will find all dredges in our system for this area and this particular time. So this is a very straightforward way to provide information on a georeferenced way using Google Earth. So let's come back to this part of the world here, the Atlantic Ocean, and actually the Cape Verdean Islands. What I want to show you is that we provide much more detailed information on each cruise if you go to additional information. So again, we have to adjust the time slider, and here we have one cruise. It's M83, and you see this link here, additional information. I click it and I have a browser in Google Earth providing me with a view on the Ocean Science Information System. I can read all the information about the gears, files in the system, and so on. What I uploaded to the LEC information is actually the 10-minute resolution cruise track in the OGC standard format, longitude, latitude, and depth, or altitude. And I also used the new GX track from Google to have time animated information. So I can download the network link for M83, which is refreshed down here, and I have to switch off all the other cruises to show it to you. Okay, so now you can see this track here. So up here the ship is actually moving backwards. So the cruise started in Dakar at Senegal, and around the Cape Verdean archipelago, and up to the Canarian Islands. But so this is not all information we have. We have an additional network link included in this network link, and if you click it to see all the information, we provide the gear information. So like the gravity cores, and some of the gravity cores in our system have a storage information, and some of them have pictures or images like core descriptions. So as long as the scientists upload this information into our system, we try to disseminate it in tools like Google Earth, or at least the web application, to give a record of the scientific work that has been done during our field expeditions. So this is the core 1384 from M83. And here you can see it. We also try to provide the information on our large equipment, like underwater vehicles, ROVs, and gliders. So what you see here are the uncleaned underwater tracks of our remote operating vehicle during this cruise. So this is all based on these track files I showed you earlier. Okay, here I opened a different cruise. It is the Maria Esmerian 22 cruise by Peter Brandt from Mindelo to Mindelo of the Cape Verdean Islands. And I wanted to show you one certain thing, how you can use the time animated track lines just to show the user a little bit more about the science you're doing. So what you see back here is actually the icon of the ship that is approaching, and if I and here in the sidebar you see that I only show you the glider events. Gliders are autonomous operating vehicles measuring oceanographic information, and so I switch on the time slider. You see the ship approaching, and events appear. So and now you see different icons actually moving around, and these are the gliders. The ship just left to the left hand side, and the gliders are actually measuring the upper 500 meters of the water column totally on their own. And you can actually show the user all this information in a time animated manner. So now the ship came back to check on the gliders if they're still on the run, and here you still see the gliders moving on their tracks. Okay, so now we are back in OSIS, and I just click through to the leg of Maria as Merian 22, and I show you right now the Files tab for this particular leg, and you see the KML network link and two files here, which are actually the track positioning of the ship extracted from the underway data system of Maria as Merian. On the event side, we also have uploaded GX event track files with the information on time-dependent positioning. So if I show you first the very easy file, what you see here is actually longitude separated by a comma, latitude separated by a comma, and altitude, and then there's a separation of a space and the next triplet of coordinates is coming. So this is the easy way. So the application is actually looking, do I have underway positioning in the usual leg track format? If not, it's simply connecting the events in their chronological order to create the minimum kind of cruise track. If in the file section there's a leg track.txt available, it will load this one, or if a GX track is available, it will load this one, and this one is a part of XML. So I formatted the timestamps into the conform GX track and when format, and so you need the exact number of timestamps and a matching number of coordinates, and I store them here again in longitude, now a space as a separator, latitude, and again a space separator, and altitude. So these text files, they are actually loaded if they're available, and if they're not available, we stick to the very simple, most simple leg track we have, just the simple connected events, and we increase the detail if we have this data available. So that's actually the whole magic behind this, that we can present time-dependent ship positioning and gear positioning simply by loading these GX event track files to the particular events and using them for the KML rendering. So thank you very much for listening, and if you have any questions, you can write me an email or just use our KML extractor, and have fun with our tools. See ya. Bye.